Welcome to the Integrating Composer with WordPress screencast. I'm Scott, one of the main developers of the popular Roots WordPress theme, and I'll be doing an introduction to Composer and showing you how to use it with WordPress. This video is a companion to the blog post I wrote on rootstheme.com. It's not a requirement to have read it first, but this video does assume that you have at certain points. I also suggest reading it regardless. If you already know the basics of Composer and just want to learn how to use it with WordPress, feel free to skip ahead to any point. Otherwise, you can just sit back and watch, although I do encourage you follow along and try out the commands, as it will definitely help you understand Composer better. The topics we'll be covering in this screencast include an introduction to Composer, a basic example, retrofitting an existing project to use Composer, some core Composer concepts, custom installers, which will lead into actually integrating Composer with WordPress, and finally some advanced usage, including managing plugins. Composer is a tool for dependency management in PHP. It allows you to declare the dependent libraries your project needs, and it will install them in your project for you. If you haven't been to the official Composer website yet, it is getcomposer.org. They have a great getting started page, and we're just going to run through this very quickly since it does a great job explaining it. As I mentioned, Composer is a dependency manager, not a package manager. This is because it installs packages on a per project basis. That means every project you use Composer with will have its own vendor directory where your dependencies are installed to. And if you're still wondering what problem Composer solves, let's put it in plain terms. You have a project that depends on a number of libraries. Some of these libraries depend on other libraries. You declare things you depend on, and then Composer will find out which versions of which packages need to be installed, and installs them. That actually means it downloads them into your project's vendor directory. Since Composer is all about managing dependencies, the first thing we need to do is actually declare them. At its most basic usage, Composer only needs a single composer.json file in your project's directory to work. As its extension might tell you, it's in JSON format. Here's an example of the minimum you need to list out your dependencies. Under Require, you simply have a list of all your dependencies with its package name and its version. Now that we've seen a basic example, composer.json, we're going to actually try it out ourselves. Before we can use Composer, we need to install it. Let's talk about the system requirements first. You need at least PHP 5.3.2 to use Composer. If you're not sure what version of PHP you have, in your terminal just type php-v. You can see that I'm using 5.3.8, therefore I can use it. First, we're just going to create an empty directory for our example. Next, under the installation instructions, as you can see, I'm using Mac OS, so I'm going to follow their Nix-based instructions. If you're using Windows, it's just as simple and right below. So, for Mac, it's a simple one command. This will actually install Composer into this directory itself. You can see that there's a composer.far, which is a PHP archive file. You can have multiple versions of Composer installed in any directory you want. I do suggest following their global instructions, which is one additional line. We're actually just going to move this file into one of our bin directories. I already have it installed, so yes, I'm going to overwrite it. What that means is, instead of typing out the long php.composer.far, you can simply type out Composer. Just typing the Composer command will give you its usage, the options, and a list of available commands, plus some short descriptions of them. Throughout this screencast, we're going to be going over a couple commands, but the one that you'll be using most often is Composer install. It actually installs the project's dependencies. If we type that out right now in our empty directory, it says Composer could not find a composer.json file. To initialize a project, please create one. As we've already talked about with this basic example here, Let's just copy this and create our file. That's all we need. Now we'll run composer install again. This time we can see that it's actually installing our dependencies. So as we specified, we wanted monologue version 1.2. It looks like the latest one was actually 1.2.1. To see what's actually happened, let's list out our directory. We have the composer JSON file that we created, a composer.lock file, which I'll go over in a minute, and our vendor directory. If we list out our vendor directory, we can see that Composer actually downloaded the monologue package locally to our folder. Understanding how versions work in Composer is very important. We required version 1.2. This means any version starting with 1.2. And if you remembered, it actually installed version 1.2.1. Now the composer lock file is very important. If we look into its contents, it contains a lot more information than we actually specified in our composer.json file. The most important thing in here though is the actual version. Simply put, the composer.lock file is a record of what specific versions of every package are actually installed. It's important to understand how Composer works with version control as well. I'm going to run through a very quick example using Git, although these concepts apply to Subversion or almost any other version control system as well. In our directory, we're going to initialize a Git repository. And if we run git status, we can see that we have these untracked files. Now we're actually going to add our composer.json and our composer.lock file. I mentioned the significance of the .lock file. It's important to keep it in version control because if another member of your team pulls down your project, the presence of that lock file will guarantee that everyone's using the exact same versions. So let's commit this, add composer. Once again, git status, and the only untracked file we have left is the vendor folder. Now it's important to understand that we actually don't want to check this into our version control. Since we're letting Composer itself manage that directory, we don't need it. In fact, all of our dependencies are declared in the .json file, so that's all we need. So we can create a .git ignore file and just add vendor. If we run git status once more, we can see that vendor isn't listed, but now we just have to add our .git ignore file. So we can say add vendor to git ignore. Now if someone clones this repository, they're only going to get these two files. They won't get the vendor directory. So there's an additional step now, which is they need to clone a project and then just run composer install. Now that we've seen Composer in action, let's talk about the benefits of it, because if we're going to invest our time learning a new tool, there better be some advantages. If there's only one reason to use Composer, it's because it's better at managing dependencies than you are. Now that means a few things. First off, you have all your dependencies declared in one file with their versions as well. You don't need to manually maintain a text file, for example. The other thing it means is that it's actually easier to install packages with Composer. You already saw how easy it was to install Monologue, for example. Composer also makes it much easier to develop in teams, either inside a company or open source development. Everyone will get the exact same dependencies and use the same tool to manage them. Hopefully you're already using version control for your projects, such as Git or Subversion. And as you saw earlier for my example with Git, Composer helps you keep your version control history cleaner by not polluting the repository with massive third-party libraries. If you want to update a version, you only need to update one file. Another advantage of Composer is Packagist. Packagist is the main Composer repository. We'll talk about repositories more later, but basically they're just a source of packages. This one is included by default in Composer, and you can get to it at packages.org. They actually have their own quick getting started guide and how to install it. You can browse packages, and let's say we go to popular packages. We can see that the top one is actually Monologue, which we already have in our composer.json. So next up we have Doctrine Common. So if you click in there, there's two helpful things on this page. First off, they tell you the latest development version. If you want to include this development version, all you have to do is copy this into your composer.json file. Below the main development version, there's actually a list of all their officially released versions. Now let's say we want the most recent stable version. It looks like 2.4 is in development and they have some release candidates, so we have to go to 2.3.0. If you click on that, once again, they have the exact strings that you need to include in your composer.json file to get that version. So now we just save that and run composer install, and we get a warning here. It says, warning, the lock file is not up to date with the latest changes in composer.json. Run update to update them. So let's run composer update. In composer.update, we can see that we're only installing Doctrine Common. That's because we've already installed Monologue. And once again, if we look in our vendor directory, we can see that we now have Monologue and Doctrine. Since we've touched on composer updates, I'll show you another example of it. If we want to change the version of a package, let's look up Monologue. They actually have a newer version than we have. We want 1.6.0. So once again, we're going to edit our composer.json file. Properly though. And we'll change it to 1.6.0. Once again, if we try composer install, we get the warning that the lock file is not up to date. Which means that we need to run composer update again. Another thing we can do, instead of running composer update for all of the dependencies in our composer.json file, is we can actually just update a single one. So we're going to run composer update monologue/monologue. We can see that it removed our previous version of 1.2.1 and installed our new version of 1.6.0. Now we're going to retrofit an existing or legacy project to use Composer. It's often helpful to see the contrast between a project that doesn't use Composer with one that does to really see how much better it is. I happen to have a project of my own that's a great example of what not to do when managing dependencies. I made an experimental WordPress theme called Radical a while ago that uses Twig for templating, and we're going to update it to use Composer. You can find this theme on GitHub under my username. And if we look in here, I did one good thing, which was I created a vendor directory, which includes Twig itself. Unfortunately, I just added the entire Twig source code into my Git repository. The worst part is I don't even know what version I've added. So what we're going to do is clone this directory locally and retrofit it to use Composer. The very first thing we're going to do, we're going to git remove this entire vendor directory because we don't want it anymore. You can see all the Twig files that we've just removed, and it's a lot of them. If we run git status, we can see that it's deleted. So let's git commit, remove Twig. And the next thing we're going to do is update our git ignore, like we did in our very first example, to add vendor. And we'll add vendor to git ignore. Now our repository is all clean, and we have no vendor directory. Now in order to get that back, all we need to do is add our composer.json file. Once again, we need the bare minimum, which is just require. And the only dependency I'm going to add is Twig. In order to find out the latest stable version of Twig, we can go back to Packagist and search for Twig, latest development version, and the latest stable. Now that we have our composer.json file, we can run composer install. If we check out our Git repository again, the vendor directory is ignored, but it's here and it contains Twig. Now we need to add our composer.json and our composer.lock file. You might be wondering, now that we actually have Twig installed in our project, how do we go about using it? One of the other benefits of Composer is that it generates an auto-load file for you. If we look in our vendor directory, we can see there's an autoload.php. They mention this on the Composer Getting Started page. It prepares an autoload file that's capable of autoloading all the classes in any of the library that it downloads. If you're used to finding an autoloader in every different project that you have, now you only have to require one. So in my code, I have to remember that in libtwig init, this is where I required the Twig specific autoloader before. You can see that if I was using a lot of different libraries in my project, I might have multiple of these requires, and I'd have to know the exact location of them, such as monologue, etc. So now we can update this to just use the general vendor/autoload file that Composer generates. If we go to the Twig homepage, another benefit of Composer is that we actually don't need the Twig autoloader register either with Composer. So I'm just going to delete that. And that's it. If we run git status, let's commit that file, use Composer autoload. And that's it for a retrofit. We're getting closer to the main WordPress section of the screencast, but first we need to understand a few core concepts. We know that in order to use Composer, you need to add a composer.json file into your directory. The act of adding this file actually makes that directory a package itself. When you add the require key, you're saying that this package depends on other packages. Up until this point, every package that we've required in our file has come from Packagist, which is the default Composer repository. A repository is simply a source of packages. So if you see a composer.json file that only has the require key, you know that they're coming from Packagist. What happens if you want to require a package that is hosted on GitHub, for example, and not Packagist? In that case, Composer makes it easy to define your own repository. We can see an example of that right here. They've listed out a custom repository that's from GitHub. We already have monologue required. So if you find monologue on GitHub itself, we can copy this and add our own repositories. It's an array in this case. And we're going to add one entry right now. And its type will be VCS, which is version control. And its URL will be the Git repository. Any repositories that you define take precedence over Packagist. So now monologue will actually be coming from this repository that we added and not Packagist. Now that we've updated this, let's run Composer install again. We can see a great feature of Composer is that it validates your JSON. I've got an error on line 2, so let's fix that. Move the colon outside. Once again, we get the warning that it's out of date, so we need to run Composer update. And that's it. We've now pulled down monologue from GitHub rather than from Packagist. I just showed you how easy it was to define your own repository as the source of a package. However, the monologue example we used already included its own composer.json, as we've seen here before. This means that it was already a composer package. The real question is, can we use a package that doesn't have a composer.json file? Since this screencast is about WordPress, let's use it as an example. Now, this screencast would be a lot simpler if we could just go to Packagist and search for WordPress and find it. Assuming it was there, you'd probably add it in something like this, WordPress/WordPress. And I don't know its version, so maybe we just add star. And then we'd run composer install. Now, as we already know, it doesn't exist. That's because WordPress isn't a real composer package. If we find WordPress on GitHub, we can see that they don't implement a composer.json file. Of course, we already showed you how to define your own repository for a GitHub repo with Monologue, so why don't we try and do the exact same thing with WordPress? If we go back to our example from before, let's clear out our file and paste this in. So we have type version control, that's correct. We will get the WordPress URL and paste that in. But once again, since they haven't implemented a vendor name and a package name, we can't just type out WordPress. We can try and run composer install and see what happens. What it's doing right now is it's trying to read the composer.json of every single tagged release on GitHub. If we go in here and click tags, there's a lot of them to scan through. This will probably take a while. The scan finally finished, and we can see the message here that says no valid composer.json was found in any branch or tag of the WordPress Git repo, so it could not load a package from it. This is what we were expecting. This is because they obviously haven't implemented a composer.json file. You're probably wondering why WordPress doesn't just add a composer.json file and make our lives easier. Well, there has been some active discussion. You can read about it on the WordPress track tickets 23912. There's a tentative milestone as 3.7, although I will not be holding my breath until that actually happens. So we're back to the original question of how do we add a repository that will get WordPress working in Composer? If we go to the Composer documentation under repositories, near the bottom there is a package type. It says if you want to use a package that does not support Composer through any of the means above, you can still define the package yourself by using a package repository. This is exactly the case that we find ourselves in with WordPress. All we need to do is actually just define some more information that would normally be found in a composer.json file. There's an example here listed out for the Smarty templating system. We'll actually just copy this in and modify it to represent WordPress's information. So the metadata that we need, type, is package, that's what we want. So package name, we're actually going to say WordPress/WordPress. I believe we would want the latest version, which as of right now is 3.5.2. There's keys called dist and source. Now, we don't actually care about the source of GitHub itself, or of WordPress itself. We're going to remove that and use dist, which means like a distribution of it. You can see that for Smarty, they're actually using a zip. Fortunately, in GitHub, if we go into releases, we'll actually use 3.6 if we can find the zip URL. So if we update this to use the GitHub archive zip and it's type zip, we don't need autoload, especially since we don't know what it would actually be for WordPress. Now you notice that we've actually set the name of the package. Before, when we were just trying to require WordPress, it obviously didn't work. Now, we'll also set this to the latest 3.6. Now when we go to actually install the dependencies, it will see WordPress/WordPress, and it will actually find that package name right in our own repository that we just defined. Let's run composer install. We can see that it's downloading the WordPress zip from GitHub right now. Let's make sure that this actually downloaded what we think it would have. If we list out our vendor directory, we have vendor, WordPress, we're going to get WordPress again, and what do you know? There's the actual source of WordPress, which is exactly what we want. You might think at this point that we're all ready to go and we can start installing WordPress, but there is another problem, as there always is. Let's go into the actual WordPress directory. WordPress needs a wp-config.php. WordPress itself is actually hard-coded to look for this file in its root and one directory up. Now, the golden rule with Composer is that since these are kind of third-party dependencies that you let Composer manage, you never actually modify anything within this folder. Since it's not checked into your version control, the local changes won't stay around anyway. So obviously we can't put a wp-config file in this folder. And if we go one directory up, we're still in vendor WordPress, so we can't add our wp-config file in this folder anyway. If we go to the root of our actual project, we can see that even if we put our wp-config in here, it wouldn't work because WordPress would not find it. So although we've solved one problem, we still have another to get past. The obvious question you're probably asking yourself is, well, why can't we just tell Composer where to install WordPress to? Unfortunately, Composer by default installs every single package into vendor, and that's for good reason, for consistency. So it might be nice if we could just go into our composer.json and have the capability to set the path, for example, to just WP. However, we can't do that. You've probably already figured out that there's a workaround for this Composer limitation, and that workaround is called custom installers. Composer lets you define a custom installer that, based on a package's type, will install it to a different path. There's actually an official Composer installers package itself that predefines a whole bunch of types, including 3 WordPress-specific ones: plugin, theme, and MU plugin. If we actually quickly just look at the source, find WordPress, we can see that each one has a custom install path into WP content. Now, once again, this would also be simple if there was a type called WordPress core, for instance, that would take a package type of WordPress core and install it into a WP subdirectory. In that case, we could easily go in here, set its type to something like WordPress core, and we'd also have to create our own require key within that package that required Composer installers one.star. If they had that type, this would work. Unfortunately, they don't. What we need is our own custom installer that defines a package type for WordPress that will allow us to install it to any subdirectory in our web root. Fortunately for us, someone's already done this. I'm going to go back to the blog post I wrote, and we're just going to search Google for this to find the GitHub repository. So it's called WebRoot Installer, and it's a Composer installer for packages that live in the web root of a project, which is exactly what we want. In fact, his example here is using WordPress. So we're going to update our composer.json to match that. The type that he's defined in his custom installer is actually WebRoot. So we're going to put that in. And then instead of requiring Composer installers, we're going to require his custom installer. There's one more thing to do at the very bottom here. You notice there's an extra. So we're going to set the WebRoot directory to just WP in this case. He had it at content. You could also type out WordPress or WordPress core, whatever you want, but I'll keep it short with just WP. And then the package name that we've defined above called WordPress/WordPress, we need to match that up. So it's going to say, find this package and install it to WP. Let's get rid of our vendor directory. And actually, let's also just get rid of our lock file. and we'll do a fresh Composer install. Of course, once again, we don't have valid JSON on line 6, and of course, the usual, we forgot a comma. So hopefully when this finishes, we're going to have WordPress downloaded into a WP subdirectory and not vendor. In the moment of truth, that's exactly what we have. Just keep in mind that you're always going to have the vendor directory, since it will have Composer itself and its autoloader and any other dependencies. Now that we have WordPress in its own subdirectory in our project's root, it's time to move forward with the install. At this point, it doesn't really matter that we used Composer to manage and download WordPress. We're just going to go ahead with the common WordPress subdirectory install, which thankfully has gotten much more popular recently. If you actually just search for giving WordPress its own directory, we can find a dedicated page to this install type in the WordPress codex. It's pretty simple, and there's just a few files that we actually need to move out of the WordPress source. So let's copy index.php and our sample config. We actually need to edit both of these files to update some paths. So we just need to update this to reference that we're actually loading it from our subdirectory. And we'll move our sample config. And at the very bottom, the most important thing is the absolute path to the WordPress directory. We need to set this to our new subdirectory as well. Now, there's one more thing you're probably wondering where it is, and that's our WP content directory. We're actually going to copy this as well from the WordPress source and move it into our root directory. The WP content folder is exactly the same as it always will be, containing your plugins, themes, and probably uploads. There's one additional tweak we can make to our setup. I personally don't like having our WordPress core folder named WP and also WP content folder. If you're trying to change directory into them, you'll always have to specify more than just WP. So in my case, I'm actually going to rename WP content to just app. Now we have a very nice separation between the actual WordPress source code and our site or application specific code. There is one more option that we have to set to actually enable this to take place. If you've heard of WP Skeleton, it's a popular WordPress setup by Mark Jakewith, who's a WordPress core team member. He actually has a similar setup where he calls this folder content. And we're just going to go in his config to pull out the two constants that we actually need to define to make it work. So near the top, we'll just put it after our database settings. We can just update this to say app, and this one as well. And that's that. Just to show off how easy it is to use Composer, we're going to go through the process of converting this into a Git repository again. So let's initialize a Git repository and run git status. We can see that all of our files are untracked as of right now. So the very first thing we're going to do is actually update our .gitignore file. We'll keep vendor in there, but we also need to add WP, since that's also managed by Composer. Git status once more, and we no longer have the WP folder as untracked. Let's go ahead and add everything else, since we actually want that in a Git repository. Initial commit. And as we can quickly see, we're actually committing just the base themes as well, which is fine for now. Now our Git status is clean. So as we went through before, if we want to, we could easily just delete our entire vendor and WP directories, and still we're on a clean Git repository. And all we have to do to fix that is run Composer install. And it will pull down our dependencies again. Thankfully, it's much faster now because it's loading from cache. And if we list out our directory, we can see that they're already back there. Since we're not making any modifications in our vendor or our WP folder, it doesn't matter if we blow these away and start from scratch again. The other benefit is that it's really easy to change our version of WordPress. If we go back into our composer.json file, right now, for example, we're using version 3.6, which just came out. If we have an issue with that, we can easily downgrade to version 3.5.2. Once we've updated the version strings, we just need to run composer updates WordPress/WordPress, and it will replace version 3.6 with version 3.5.2. And if we run git status, the only things we've actually changed are the two composer files. So we're going to add those and commit them and say downgrade to WP 3.5.2. Way easier and much simpler than manually having to download the WordPress zip, unzip it, and replace the files. The final step is to actually install WordPress to prove that our new setup with Composer actually works. I'm going to edit our config to update my database settings. Let's just call it WP_Composer. I have a virtual machine running, so we're just going to update the credentials to match that, and we'll save it. I have it running on a local subdomain. So obviously, since WordPress is in our subdirectory, we need to add the WP to it to get to the install. Just name it WP Composer. And we'll install WordPress as usual. If you're not familiar with installing WordPress in a subdirectory, the very final step is in your general settings. You have to remove the subdirectory from the site address URL. We'll save that. And now when we go to our site, you can see that there's no subdirectory and everything works. Now that we have Composer managing WordPress itself as a dependency, our next major issue to tackle is how to manage plugins. And obviously the answer to that is we're going to use Composer as well. Now, have you seen before from our foray into packages and the composer.json file, by default, anything that you require here comes from packages. Of course, we can get around that by defining our own repositories. So ideally, plugins would already be found on packages. If we go into packages and do a quick search for WordPress, for example, it might take you a while, but you can find some WordPress plugins in here. Here's one, for example, WordPress plugin for showing tweets. So if we wanted to install this one, all we need to do is add it to our require section. I'm going to show another command which we haven't used yet. Instead of manually editing the composer.json file, you can actually type out composer require and the package name. It will prompt you to provide a version constraint. If we look down here, obviously the only stable version is v0.3.0. And it mentions that the composer.json file has been updated. You can do it either way, but sometimes this is a little simpler than manually writing out the JSON yourself. If we go back and look, we can see that it has been added correctly. If you noticed, running composer require actually ran composer install as well. Now it's time to actually find out where this plugin was installed to. Let's list out our vendor directory, and we can see that it actually installed it in there. Of course, that's not going to work. For WordPress, we need plugins in our plugins directory. Now, unfortunately, this plugin didn't use the Composer installer's custom installer that we looked at before. If we do a quick refresher about Composer installers, we know that a package has to set its type to WordPress plugin, and it also has to require this Composer installers as well. So now our problem is any plugin that we want to use in WordPress has to be a Composer package that requires this custom installer and sets its type properly. Now, since Composer is quite new and not even that active in the WordPress community, obviously there's going to be very few plugins that actually meet these requirements. Luckily, there is an easy workaround for this. What we need is a repository of packages that satisfy this requirement of having Composer installers and the package type set to WordPress plugin. Just like Packagist is the official and default Composer repository, someone has created WPackagist. What this is it's a mirror of the WordPress plugin directory as a Composer repository. In order to use it, all you need to do is add this custom repository to your composer.json file. So let's open that up. We already have one custom repository for WordPress, so we're just going to add another one. Its type is simply Composer, and the URL is just the website URL that we are on right here. Now that that's added, we can actually start listing out plugins underneath require. There's two example ones here that we'll paste in. The important thing to notice is that the vendor name is always WPackagist. If a package is coming from this new repository, that has to be your vendor name. So let's save that and run Composer update. It's important to remember that by default, these things implement the WordPress plugin type from the Composer installers. And as we saw before, the predefined install path for WordPress plugins is actually WP Content plugin's name. Now, if you remember, we've actually renamed our WP Content directory to app. So this won't work exactly as we want yet, and I'll show you how to get around that. If we list out our get status, we can see that Composer actually created this WP Content. If we list it out, we have plugins, and we actually have the two plugins that we installed. Keep in mind that what you name your original WP Content directory is just personal preference. If you want to leave it as WP Content, this will already work as is with the default plugin path. But since we changed ours to app, how do we get these packages to install in the correct location? Thankfully, any package that implements Composer installers actually lets you to overwrite and set a custom install path. They have an example right here for WordPress plugin. So we're going to add this into our composer.json file. Under the extra key, we'll just paste this in. And the path that we actually want is app and just plugins. And it's a WordPress plugin, so we'll leave it as that. Now we can run Composer update once again. And hopefully our packages will now be in the correct location. So if we run a get status, we can see that they're under app plugins. App plugins, post a post, for example, exactly as we want it. We can actually go ahead and remove the WP content directory that Composer had originally put our plugins in, since we don't need it. Throughout this screencast, we've also been focusing on how Composer interacts with the Git repository. And we've seen that we've ignored the vendor directory and the WP directory. By rule, any folder that Composer manages as dependencies, you don't want to commit in your repository, meaning you should ignore it. So if we run git status once more, first let's just commit our Composer JSON and lock files, add plugins, we'll get that out of the way. And once again, now we have our actual plugin directories that are untracked. But as I was just saying, we don't want to commit those into our Git repository. So we need to add them to our .gitignore file. We can add app, plugins, and if we run git status once more, we notice that they're no longer there. So we'll update our add plugins to gitignore. Now there's one catch from this. This works great for any plugins that you're getting from the WordPress plugin directory, for example, or in this case, the ones that are mirrored to WPackagist. Occasionally, you may have an internal plugin that you're doing the proper practice and kind of taking it out of your actual theme code and putting it into a plugin, but you don't want to share it or you don't want to have it on the WordPress plugin directory. In this case, let's go into app plugins and let's just copy out post to post, but we'll rename it to custom plugin. Now, since this isn't managed through Composer, the problem is that since we ignored our app plugins directory in Git, there's no record of this at all. If someone pulled down this repository right now, they wouldn't have that plugin. So what we want to be able to do is, by default, ignore every directory in app plugins, but actually whitelist certain ones. So in Git, we can do that by once again editing our git ignore file. If you're not too familiar with git ignore, we actually have to change this existing app plugins one slightly. This line says ignore the entire directory. We need to actually change this to say ignore anything within that directory first. Then afterwards, if you add an exclamation mark at the start of a line, we'll actually negate that. So now we can basically create a whitelist of plugins that we don't want to ignore. So we called it custom plugin. So we'll save that, and then we'll run git status. And now you can see that this plugin appears as untracked, while none of the other composer managed ones do, which is just what we want. So let's go ahead and add this, and we'll commit everything and say add custom plugin. Let's take a look at the git ignore once more just to go over that again. So we're saying ignore everything within this directory except this directory. And we could change this to be any other ones you want. You could say Twitter plugin, and you could keep listing these out. While it is a hassle to maintain this whitelist in our git ignore file, I should mention that it probably won't happen too often. Most plugins people use do come straight from the WordPress plugin directory, and in this case from wpackagist, or for example from a public GitHub repository. If you do have one that you do need to whitelist, it's probably best to look into maybe maintaining a private Git repository first. Then that way you could at least list it under the dependencies in your composer.json file, which means that you wouldn't have to whitelist it. The whitelist is only used for local directories in there that aren't managed through Composer. Let's take a look at our actual directory and what it's set up like right now that we have everything working. Once again, we have our site or application specific code in app. We have our necessary Composer files which manage our dependencies. The only other two files we have in the root of our directory are index.php and wp-config.php. These are required by WordPress to be in there, and there's nothing we can do about that. Then we have our vendor directory and our WP directory, which are all managed by Composer. So it's very clean, and we have a nice separation between our dependencies and our actual application code. Let's take a look at what a normal WordPress site would look like. If we go to WordPress site and list out this directory, this is what you typically get if you just downloaded WordPress, unzipped it in your directory, and started working away. We have all the WordPress files and its core mixed together with your WP content. Once again, the difference should be visible at first glance. It's not simply just that there's less files in one compared to the other. It's that there's a good separation of concerns. And as I've been continually mentioning throughout the screencast, it really impacts your version control history as well, and what files you're keeping committed in it. If we initialized an empty Git directory in here, and did a full git add, and ran git status, this is going to go on for a long time. The WordPress core is huge, and we definitely don't want to be committing that in your repository. Finally, let's take a look at what it actually takes to get set up from scratch with this new Composer setup. For example, if you had to clone the project on a new laptop, or if you had a different team member using it, or if you shared it on GitHub, for example. So if we go out of this directory, we'll actually delete this WordPress site directory. And as you know, we have been maintaining a Git repository in this directory. So I'll simply actually git clone this into WordPress site again. If we go back into here and list it out, compared to our original, you can see that we're missing a vendor and WP. And if we look in at plugins, we only have our custom plugin. This is as we expect it, so let's run Composer install. Once again, this is quite quick because Composer maintains a cache, which is another advantage of it. We list it out again, and now we have our vendor and WP directories and our app plugin directories. Going back to the benefits of Composer, say I'm starting at a new company, it's my first day there, and I want to work on their main WordPress site. So I clone the repository as I just did. I can easily go into the Composer JSON file. I can see exactly which version of WordPress they're using, all the plugins they're using and their versions, and the settings for the site. Although it has taken us a while to get to this point, and a lot of workarounds, I hope that now that the hard work has been done, that you're excited about using Composer and you see the benefits of it. I've gone over some of the Composer commands and definitely given you guys a good intro to it, but the only way you'll really get to know Composer in depth is by using it yourself. Thanks for watching this screencast. I hope that you learned a lot about Composer and WordPress itself from it, and hopefully we'll have more of these videos coming soon.